Hi guys, on today's video we're still on financial mathematics, and previously we did discuss the so-called simple interest, and I did say to you financial mathematics, as much as it's called financial mathematics, it's just the mathematics of investments. So previously we did discuss simple interest already, and we talked about simple interest rate as well. So like I said, with simple interest, just go to the bank once, you invest whatever you put down as your investment, and then they will tell you what's the interest rate, like how much are you going to earn from it. The interest you're going to, like the rate determines how much you're going to earn from the down payment that you put. And then you wait for a specific period that you agreed on the investment on. So if it's 5 years, you're going to wait for 5 years, you come back after 5 years, you'll get whatever you invested with an interest rate with an interest and determined by the rate that was given. So for instance, if you put 100 rands, and then you come after 5 years, you'll get 100 rands with an interest rate of 15% if that was the agreement for a period of whatever agreement it was. So that's straightforward. So what I'm trying to say in simple terms is you go once, you put the money once, you agree on what interest are you going to earn at whatever period that you're investing the money for. You come back after the period, and then you get the money as it is. That's simple interest. With compound interest mean interest on interest. So you actually get an interest on the accumulated amount that you put down. So for instance, the story would goes like, if you would put some investment for 5 years, and then they would say to you it's going to be compounded yearly, meaning it's going to be reinvested yearly. So if you put 100 rands and then after a year it was supposed to earn 15%, it's going to be 115%, right? Unlike simple interest, whereby the following year you would get 15% uniformly as it is, with compound interest, the amount that was accumulated, it becomes automatically reinvested, which is like kind of hard to swallow the pill, because if you look at it in that form, it looks way complicated and diverse. But then let's try to see if you can break it down like in an order where it would be more simplified, because that's the whole point. That's the whole point, to simplify things. So look at it like this. With compound interest, ideally, suppose again you put down 100 rand for say a period of 5 years at an interest rate of say 15%. What we expect to see here at the end of year one, we expect your interest to be the amount that you put down, the 100 rand that you put down, plus 15% of it for the first year, which is going to give you probably 115, right? So at the end of the year one, if you put 100 rands down for 5 years at an interest rate of 15%, after the first year, it would be 100 rand plus the 100 rand multiplied by the 15% that you put down. I've already divided it by 100% there, and then you get 115. Now, look at this. At the end of year two, in compound interest, instead of getting another 15% for the following year, which is going to be like 130 now, no, that's not how it works. With compound interest, this one is reinvested, meaning that's when you will have this amount reinvested again to can earn interest on its own. So that would be this amount coming here, right? But you already know that if you were to take a common factor here, you would get 100 is 1 plus 0.15, specifically for this one only. If I was to take a common factor out here, I would get 100 out, 100 out. It would be 100. Where there was 100 here, would have 1, and then 0.15 for the other one, right? But then, instead of writing the 115 like this, because I want to manipulate everything for us to understand the equation, how it comes about for compound interest, I will write the 115 as it is here. So now, for the following year, it will be the investment of this 115. We know this is 115. So now this is my down payment as it is. This is my 115. This is my 115. All of it. It represents the whole thing here. This is my 115. And then if I put it down now, I will have this. If I put it down now, I will have this as my down payment. And then it has to be this plus as my down payment plus 15% of my down payment as it is here, plus 15% of this, plus 15% of this. To get 15% of this, I just multiply it by 15%. I just multiply it by 15%. I don't know what value am I going to get, which will give us 132.25. But somehow 132.25, it's somehow a bigger value than what I could have got if it was simple interest. Because if it was simple interest, I could have gotten 130. But that's not what I want to argue. What I want you to understand is that from here, if I take out a common factor again from here, my common factor here being the money that I put down, which is this and this, but I multiplied it by 0.5. If I take the common factor down here, I will have 100 rands into 1 plus 0.15, which I put out, this one and this one. And then what would be left out? It's going to be 1 plus 0.15, because it's 1 here, and then it's 1 multiplied by 0.15 here. And if you see, now, the way it goes, it forms some sort of an exponential vibe, because this and this are identical, and then we get that. Trust me, from here, if I was to find year 3, I would still find that year 3 is 101 plus 0.15 to the exponent 3. So it goes on and on. So now I can see the trend. Year 4 will be to the exponent 4. Year 5 will be to the exponent 5. Hence, mathematicians came up with the proper equation for calculating the accumulated amount under compound interest, which is looking at the trend as it goes and goes and goes. You can see that it's building some sort of an equation which we can use right now. And I know that a lot of people are familiar with this equation. Let me show you the equation, how it looks like. So for compound interest, this is the formula. A mere high school student would actually be familiar with the formula like this. So for compound interest, this is how the formulas looks like. This formulas is the same thing. I just use this notation because this is the one they use normally in high school in South Africa, and this is the one they normally use in university, but then mostly different institutions. S and A, they stand for the same thing, is accumulated amount. So it's the amount you get after the investment. If you can see, the right-hand side is the same. The left-hand side is just, like I say, similar. A is equals to S if you want to look at it in terms of algebra. But here's the thing, with compound interest, it has the so-called compounding period. And then compounding period differs. Hence, unlike simple interest, you go once, you invest, you go home, no complications, nothing to recalculate, stuff like that. It's straightforward. With compound interest, you can have different types of compounding period. So they can tell you that your invested will be compounded yearly. That means that your investment will be reinvested yearly. So every year it will be reinvested, meaning whatever you have accumulated at that moment, it becomes a present value of the whole thing, be reinvested as a new investment now to grow your investment like that. So to be more specific, compound interest, it kicks ass more than simple interest does, because it gives you a little bit of more interest for yourself in the form of money as money value, because the interest rate keeps on reinvesting all the accumulated amount. Compound, like I said, compound interest is reinvesting all in all like that. So with that being said, these equations that I wrote down here, they are only applicable only if it is compounded yearly. Now, because this is simplified RSA. The guys who makes it looks easy. I wouldn't recommend that you look at, it's not wrong, it's totally correct, but then always picture it as its advanced form. And its advanced form is the one which sums up everything at once, so can help you calculate or to can help you solve any problem. I repeat, as much as these equations, they are the equations we use for compound interest, the equation as it is, depending on your understanding of mathematics, don't allow yourself to picture it as the only equation of compound interest. Otherwise, let's advance it like this, because we must determine the compounding period. So something can be compounded yearly, something can be compounded quarterly, and you must know that we determine how to determine 4 quarters in a year, right? We have 4 quarters in 1 year. Something can be compounded half annually, which is like 6 months, 6 months. So talking about compound periods on the investments, an investment can be compounded monthly under compound interest. So meaning every month it's being reinvested. That's what it means. So if it's compounded semi-annually, it means twice every year, meaning 6 months, 6 months is being reinvested. If it's compounded quarterly, you must know to determine that we have 4 quarters in a year. 3 months, 3 months, 3 months, 3 months for 12 months. And then every 3 months your investment will be reinvested. If it's invested, what else? If it's invested weekly, you must know every week your investment will be reinvested. If it's invested daily, you must know we have 365. Hence, some students, they are likely to be given a calendar at the back of the question paper if you are writing financial mathematics, so you can be able to work around the days and whatsoever. But we'll get from that. For now, we're still just on the introduction, right? So if you see your formulas like this, you must always know that the value of I is equals to R interest rate divided by N, which would be the compounding period in this case. And then N, the variables doesn't matter, but then I just want you to look at the equation. This equation is exactly the same as this. I want you to look at if you are doing grade 12, I want you to look at it like from this. Always use this one, because this one, it works all the time. Even if they can say it's compounded yearly, if you put 1 on the compounding period, automatically it becomes that. So rather you look at it like this more than you ever look at it like this. So this is the powerful one that can solve all your problems. This is for if you are in grade 12. This is how the formula looks like for grade 12 students. But then for university students, we have the very same similar thing. Like I say, the variables don't matter. So for university student, for the I, they show it as JM over M, M being the compounding period. Same applies with the N. The N is equals to MT, which is the compounding period multiplied by time. The compounding period interest rate divided by the compounding period, which makes the formula to be this. S is equals to P1 plus, instead of I, you know that I is equals to JM over M. JM over M is substituted there, and then for N is equals to TM, and then N is equals to TM. M being the compounding period. Here, N being the compounding period. These two formulas are the same. This is the very same thing. I just use the notation that normally is used in university level, and this is the notation that is normally used in high school level. But these are the same formula. A and S represent the same thing. P is the present value as usual. R is your interest rate. Even JM here is your interest rate. N here is the compounding period. M here is the compounding period. T is the term or the time, term and the time, and then M. If an investment is compounded yearly, M would be 1. If it's compounded monthly, M would be 12. If it's compounded quarterly, M would be 4, because we have 4 quarters in a year. Same applies here. If an investment is compounded yearly, N would be 1. If it's compounded monthly, N would be 12. If it's compounded weekly, N would be 52 because we have 52 weeks in a year. So this is the equation of compound interest. This is how the equations look like. Like I say, these two equations are the same. Now, I'm trying to use both the notations for high school and university students just to make you understand that whatever you do in high school, it continues when you get to varsity level. As much as variables can be changed, but then it's still the very same thing. So regardless of how you look at it, if you calculate the accumulated amount, it's still going to be the same. Join me on the next video as I break down the equation under compound interest, and then also show you the ideal question on how the question can come about on an exam, and then also give you some armor so you can be ready on how to answer the question. Otherwise, in the meantime, please subscribe to our YouTube channel, follow us on Facebook, like our videos on Instagram, follow us on TikTok as well. I'm Mr. Maimane. This is Simplified RSA, the guys who makes it look easy. Let's continue making things look easy on the next video. Cheers.